If you think 32 PSI is always the right number for your tires, you need to hear this before your next fill-up. One dangerous assumption, repeated by millions of drivers across America every single day, is directly connected to premature tire wear, handling problems, poor fuel economy, and, in the worst cases, catastrophic tire failure at highway speeds. And here is the shocking part. Over 80% of American drivers inflate their tires to a random number they heard somewhere without ever checking what their specific vehicle actually needs. Gas station attendants repeat it. Online forums suggest it. Even some tire shops default to it. Yet this one-size-fits-all approach ignores the precise engineering that went into your vehicle and can turn perfectly good tires into expensive problems waiting to happen. By the end of this video, you will understand why blindly using 32 PSI without checking your door jamb is one of the most dangerous shortcuts in automotive maintenance and what you should be doing instead. Before we go on, subscribe to AutoJ World. This channel is about real mechanics, real safety, and real information that protects your car and your wallet. The truth about tire pressure could save you thousands of dollars and potentially save your life. Now, let's expose the myth that almost every American driver believes. Number 1. The dangerous myth of universal tire pressure. Walk into any gas station in America and ask someone what tire pressure they use. The answer is almost always the same, 32 PSI, maybe 35. Sometimes people say whatever feels right, or around 30-something. What you almost never hear is, "I checked my door jamb this morning." And that is the beginning of a problem that costs American drivers billions in wasted fuel, premature tire replacement, and avoidable accidents every single year. The myth started somewhere reasonable. Many vehicles from the 1990s and the 2000s did specify 32 PSI. It became a convenient number, easy to remember, and close enough for most cars. So it spread, person to person, generation to generation, until it became automotive gospel. But here is what nobody tells you. Automotive engineering did not stop in 2005. Modern vehicles are heavier. Tire technology has evolved. Load distributions have changed. Electronic systems now depend on precise pressure readings to function correctly. A 2015 Honda Accord and a 2024 Toyota RAV4 might both look like they would use similar tire pressure, but one needs 32 PSI and the other needs 36. The difference is not preference, it is physics. When a team of engineers designs a vehicle, they do not guess at tire pressure. They run thousands of tests, calculate weight distribution across all four corners, analyze suspension geometry, measure braking distances, test handling limits, and determine the exact pressure that balances safety, comfort, tire wear, and fuel economy for that specific vehicle with that specific tire size. Those numbers end up in one place, the tire information placard on your driver's side door jamb. Not 32 PSI for everyone, not a rough estimate, an exact specification designed for your vehicle. And when you ignore it, everything the engineers calculated falls apart. Number 2. How the wrong pressure destroys tires invisibly. Most drivers think tire damage is obvious. You will see a bubble, feel a vibration, hear a noise. But the most expensive tire damage happens completely silently, building month after month until the day your tire fails without warning. It all starts with the contact patch, the small area of rubber actually touching the road at any moment. This patch is engineered to distribute the vehicle's weight evenly across the tire tread. When pressure is correct, the entire tread surface makes contact, load spreads evenly, heat dissipates properly, and the tire wears uniformly. But change the pressure by just 4 PSI in either direction, and that carefully balanced contact patch distorts dramatically. Underinflate by 4 PSI and the center of the tread, lifts slightly off the road, while the outer edges press down harder. Those edges now carry weight they were not designed to handle. They flex more with every rotation, generating excessive heat. Rubber compounds break down faster. After just 10,000 miles, those outer edges can wear down to dangerous levels while the center still looks new. Now here is the expensive part. Most tire manufacturers will not warranty a tire with uneven wear. They consider it improper maintenance. So you just bought tires that should last 50,000 miles, and you are replacing them at 20,000, paying full price because you were 4 PSI low the entire time. Overinflation does the opposite, and it is equally destructive. Too much pressure forces the center of the tread to bulge outward. The tire now rides on a narrow strip down the middle. Side tread barely touches the road. That small contact area works harder than it should, generating concentrated heat and wearing quickly. But the real danger is not the wear. It is what overinflation does to impact resistance. Tires are designed to absorb shocks from potholes, debris, and road imperfections by flexing slightly. An overinflated tire loses that flexibility. It becomes rigid. When you hit a pothole at highway speed with an overinflated tire, instead of absorbing the impact, the tire transmits the full force to its internal structure. Steel belts can separate. Sidewalls can develop bulges. Internal layers can delaminate. All of this happens inside the tire where you cannot see it until the day it fails catastrophically. According to National Highway Traffic Safety Administration data, improper tire pressure is a contributing factor in 660 traffic fatalities every year. Not bald tires, not blowouts from road debris, improper pressure. The tires looked fine from the outside. Number 3, why your vehicle's engineers know better than the internet. Every vehicle sold in the United States has a tire information placard. It is federal law. The placard is on the driver's side door jamb, clearly visible when you open the door. It lists the exact cold tire pressure for your specific vehicle, usually different numbers for front and rear, and sometimes different pressures for normal driving versus fully loaded conditions. This is not a suggestion. It is the result of millions of dollars in engineering and testing. The engineers who designed your vehicle measured its exact weight distribution. A front-wheel drive sedan carries more weight over the front axle because of the engine and transmission. That is why many specify 33 pounds per square inch in the front and 32 pounds per square inch in the rear. It is not random, it is balance. The front tires need slightly more pressure to properly support that extra weight, maintain correct steering response, and prevent premature wear. An SUV might specify 35 pounds per square inch in all 4 tires because weight distribution is more even and the vehicle's center of gravity is higher, requiring firmer tires to maintain stability during cornering. A pickup truck might list one pressure for normal driving and a higher pressure for towing or hauling. These are not options. They are requirements for safe operation under different loads. When you ignore those numbers and just pump everything to 32 pounds per square inch because that is what your neighbor does, you are betting against teams of professional engineers who spent years getting it right. You are assuming you know better than the suspension designers, the tire engineers, and the safety testers. And you are wrong. But the consequences do not show up immediately. That is what makes this mistake so insidious. Your car does not shake violently. The check engine light does not come on. Everything feels roughly normal because modern vehicles are incredibly good at hiding small problems. Meanwhile, your tires are wearing unevenly, your fuel economy is dropping by 2 or 3%, your tire pressure monitoring system is using incorrect baseline values. Your handling is subtly degraded. Your stopping distance in an emergency is several feet longer than it should be. You will not notice any of this until months later when you are replacing tires early or, in the worst case, experiencing a blowout at 75 miles per hour because the tire's internal structure finally gave out from operating outside its design parameters for thousands of miles. Number 4. The cold tire pressure rule everyone ignores. Mechanics hear this question constantly. Why is my tire pressure different every time I check it? The answer is simple. You are checking it wrong. Tire pressure changes with temperature. For every 10 degrees Fahrenheit change in ambient temperature, tire pressure changes by approximately 1 PSI. But that is just external temperature. Internal temperature from driving affects pressure even more dramatically. The moment your vehicle starts moving, friction between the tire and the road generates heat. That heat is intense. Highway driving can raise tire temperature by 50 degrees Fahrenheit or more. As the air inside heats up, it expands and pressure climbs. A tire that reads 32 psi cold can easily read 36 or 37 psi after 20 minutes of highway driving. This is completely normal. The tire is not overinflated. The air is just hot. But here is where drivers make a catastrophic mistake. They check tire pressure at a gas station after driving for 15 minutes. The gauge shows 37 psi. They think that is too high because the door jamb says 33 psi, and they release air until the gauge reads 33 psi. Problem solved, right? Wrong. Disastrously wrong. They have just underinflated their tires by 4 psi. Here is why. The pressure specification on your door jamb is always without exception for cold tires. Cold means the vehicle has been parked for at least 3 hours, long enough for the tires to return to ambient temperature. When you check hot tires and adjust them to the cold specification, you are guaranteeing they will be underinflated once they cool down. Later that night, parked in your driveway, those tires cool to ambient temperature. The hot air contracts and pressure drops. Now your tires are sitting at 29 psi when they should be at 33 psi. You might drive them like that for weeks, possibly months, slowly destroying them from the inside, until one day you check them cold and discover they are mysteriously low. Not mysterious at all. You did it yourself. The correct procedure is dead simple, but almost nobody follows it. Check tire pressure in the morning before driving, when the tires have been sitting overnight and are at ambient temperature. That is the only time the reading is accurate. That is the only time you should inflate or deflate. If you absolutely must check pressure after driving and you discover a tire is actually low, add enough air to bring it slightly above the recommended cold pressure, then check it again the next morning when cold and adjust to the exact specification. Never reduce pressure in a hot tire. Never trust a reading taken after driving. The air inside is lying to you. Number 5. The TPMS system you are accidentally sabotaging. Since 2008, every new vehicle sold in the United States has been required to have a tire pressure monitoring system, which we call TPMS. These systems are designed to warn you when tire pressure drops dangerously low, usually when it falls 25% below the recommended pressure. But there is a critical step that almost everyone skips, and it turns this safety system into a liability. TPMS systems need to be told what correct pressure is. When you inflate your tires, the system does not automatically know what you did. It is still using the old baseline values from the last time it was calibrated. Here is what happens when you skip the reset procedure. You inflate all 4 tires to the correct pressure. You drive away. The TPMS system still thinks your tires are at the old pressure, for example 29 psi, because they were low. 2 weeks later, one tire develops a slow leak and drops to 30 psi. That is 3 psi below where it should be, a significant loss. But your TPMS does not alert you. Why? Because it thinks 29 psi is normal. It will not warn you until that tire drops to 25 PSI, which is 25% below the actual 33 PSI specification. By that time, you are driving on a severely underinflated tire. The exact scenario TPMS was designed to prevent is happening while your dashboard shows no warnings. The correct procedure is simple, but it varies by vehicle. Most modern cars require you to turn the ignition to the on position without starting the engine. Access the vehicle settings through the dashboard or infotainment screen, find the TPMS reset or relearn option, and confirm. Then you need to drive at a steady speed, usually above 30 miles per hour, for several minutes so the system can detect and store the new pressure values. Some vehicles require a TPMS reset button under the steering column. Others reset automatically after driving for 10 minutes. Check your owner's manual for the specific procedure for your vehicle. Skip this step and you are essentially disabling your tire pressure monitoring system while believing it is protecting you. That false sense of security is more dangerous than having no system at all. Number 6. Mixing up front and rear specifications. Quick question. Do your front and rear tires need the same pressure? If you answered yes without checking, you just revealed exactly why this mistake is so common. Many drivers assume all 4 tires should match. It seems logical, balanced, symmetrical. But physics does not care about symmetry. It cares about weight distribution. Most front-wheel drive sedans carry significantly more weight over the front axle than the rear. The engine, transmission, and sometimes the battery are all mounted up front. That can be 60% or more of the vehicle total weight sitting on 2 tires. The rear tires, supporting the trunk and rear passengers, carry far less load. Because of this uneven distribution, many vehicles specify different pressures from front to rear. A common specification might be 35 pounds per square inch front and 33 pounds per square inch rear. Those 2 pounds per square inch make a critical difference. They are calculated to equalize the contact patch size between front and rear tires despite the different loads. If you inflate all 4 tires to 35 pounds per square inch because that is what is printed on the air compressor, you have just overinflated your rear tires by 2 pounds per square inch. That does not sound like much, but it is enough to reduce rear tire contact with the road and decrease traction, especially in wet conditions. It is enough to make the rear end more prone to sliding during emergency maneuvers. It is enough to cause the rear tires to wear faster in the center while the fronts wear normally. Trucks and sport utility vehicles often have the opposite specification: equal pressure all around, or even higher pressure in the rear, depending on bed or cargo capacity. Some vehicles list different pressures for different load conditions. Light load might be 32 pounds per square inch all around. Maximum load might be 35 front and 38 rear. These are not suggestions for comfort. They are engineered safety specifications. When load increases, the suspension compresses, the center of gravity shifts, and tire pressure must change to maintain a proper contact patch and prevent overheating under increased weight. Ignoring these specifications does not just risk uneven tire wear. It risks loss of vehicle control, understeer in wet corners, longer emergency braking distances, and reduced stability when carrying passengers or cargo, all because someone decided close enough was good enough. Number 7. The temperature swing nobody accounts for. You check your tire pressure on a warm September afternoon. It is 75 degrees Fahrenheit outside. All 4 tires read exactly 33 pounds per square inch. Perfect. 3 months later, it is January, and temperatures have dropped to 25 degrees Fahrenheit. You have not touched your tires, and now they are sitting at 28 pounds per square inch. You did not lose air. The tires did not leak. Physics happened. For every 10-degree Fahrenheit drop in temperature, tire pressure decreases by approximately 1 pound per square inch. A 50-degree Fahrenheit temperature swing between summer and winter means your tires can lose 5 pounds per square inch without any leak or damage. It is just cold air contracting inside the tire. This is why so many TPMS warnings light up on the first cold morning of fall. Overnight, the temperature drops 30 degrees Fahrenheit, and suddenly all 4 tires are 3 pounds per square inch low. Drivers panic, thinking they have 4 simultaneous leaks. They do not. They just need to add air. But here is where the mistake compounds. That same driver adds air in the winter, bringing tires back up to 33 pounds per square inch. Spring arrives, temperature climbs back to 75 degrees Fahrenheit, and those tires are now at 38 pounds per square inch, 5 pounds per square inch over specification. Overinflated all summer long because nobody adjusted for the seasonal temperature change. The correct approach is to check and adjust tire pressure with every significant seasonal temperature change. When fall temperatures drop, check pressure and add air to compensate. When spring temperatures rise, check pressure and release excess air. This is not optional maintenance. This is keeping your tires within their design parameters year-round. Professional fleet managers and racing teams check tire pressure before every single drive because they understand how much temperature affects performance and safety. Consumer drivers should check at least monthly and always before long trips. Temperature swings in either direction can push tires outside safe operating range within days. Number 8. The spare tire everyone forgets. Here is a scenario that plays out thousands of times every day across America. A driver gets a flat tire, pulls over safely, opens the trunk, pulls out the spare, jacks up the car, removes the flat, installs the spare, lowers the car, and discovers the spare is also flat. Roadside assistance data shows this is one of the most common calls. The spare tire, completely forgotten and sitting in the trunk for years, has lost so much pressure it is unusable. Now the driver is stranded waiting for a tow truck, all because nobody checked the spare. Spare tires lose pressure just like regular tires, about 1 PSI per month naturally. If your spare has not been checked in 2 years, it has lost 24 PSI. It started at 60 PS1, the specification for most temporary spares, and now it is at 36 PSY. Technically inflated, but dangerously low for actual use. Here is what makes this worse. Temporary spare tires, the small donuts, require significantly higher pressure than regular tires. Most specify 60 PSI. Some require 65 PSY. This is not a mistake. These tires are narrower and light-duty. They need high pressure to safely support the vehicle's weight for short distances. The temporary spare is designed for short-term use only. When drivers find a spare with low pressure, they sometimes inflate it to 35 PSY, thinking that is close enough to their regular tires. That spare is now operating at barely half its required pressure. It is structurally compromised, and the driver may be about to drive on the highway at 60 miles per hour on a tire that is essentially half flat. The correct procedure is simple. Every time you check your main tires, take 30 seconds to check the spare. Keep a pressure gauge in your trunk. Most spares are easily accessible by removing the trunk floor panel. Check the pressure. If it is low, add air to the specification printed on the spare tire itself, usually around 60 PSI. This one habit prevents the embarrassing and potentially dangerous scenario of discovering your safety backup is useless exactly when you need it most. Number 9. Trusting gas station gauges and equipment. Walk into any gas station and find the air pump. Look at the built-in pressure gauge. That gauge has been used thousands of times. It has been dropped, frozen in winter, baked in summer sun, and never calibrated. And you are trusting it to give you accurate readings. Gas station air equipment is notoriously unreliable. The pressure gauges can be off by 3 to 5 PSI in either direction. Sometimes the gauge sticks. Sometimes the connection leaks, showing falsely low readings. Sometimes the compressor output is inconsistent. Tire shops see this constantly. Customers come in complaining their TPMS light will not turn off. All 4 tires read 35 PSI on the gauge. The shop checks with calibrated equipment. The actual pressure is 31 PSI. The gas station gauge was wrong by 4 PSI. The driver has been underinflating their tires for months, relying on a broken gauge, and wondering why they keep getting warning lights. The solution costs less than $20. Buy your own digital tire pressure gauge. Keep it in your glove box. Digital gauges from reputable brands are typically accurate within plus or minus 0.5 PSI when properly calibrated. They are easy to read. They work in any weather, and they give you consistent, reliable readings. Before inflating at a gas station, use your own gauge to check the current pressure. Note the difference from the specification. Inflate using the station equipment. Then immediately check again with your own gauge to confirm the actual pressure. Adjust as needed. This 2-step verification ensures you are not relying on equipment that might be giving you completely false information. Professional mechanics use calibrated gauges that cost hundreds of dollars and require annual certification. You do not need that level of precision, but you do need something better than a gas station gauge that nobody has checked in 5 years. Number 10. The load condition variable nobody reads. Pull out your owner's manual right now. Turn to the tire pressure section. Many vehicles don't just list one pressure specification. They list 2 or even 3 different specifications for different loading conditions. For normal driving, 33 PSI front, 32 PSI rear. For maximum load or highway speeds above 100 miles per hour, 36 PSI front, 35 PSI rear. These are not optional performance tweaks. They are safety requirements based on physics. When you load a vehicle to maximum capacity with passengers, cargo, or towing equipment, the suspension compresses and the tires support significantly more weight. If pressure is not increased to compensate, the tires will overheat from excessive flexing under load. This is exactly what caused the infamous tire failures in the late 1990s. Vehicles loaded beyond their tire pressure specifications, driven long distances in hot weather with tires that could not dissipate heat fast enough, experienced steel belts separating. Tires failed catastrophically. People died. The engineering is simple. More weight requires more pressure to maintain a proper contact patch and prevent dangerous heat buildup. If you regularly drive with a full load of passengers or cargo, use the maximum load pressure specification, not the normal driving specification. The same applies to highway driving. At speeds above 70 or 80 miles per hour, centrifugal force and increased heat generation can require higher pressure for some vehicles. The owner's manual or the door jamb placard will specify this if it applies to your vehicle. Ignoring load specifications is gambling with tire integrity. You might get away with it on short trips in cool weather. But take a fully loaded family road trip in summer, driving 75 miles per hour across Arizona on underinflated tires, and you are creating the exact conditions that lead to catastrophic failure. The tires cannot tell you they are overheating. They just fail. Number 11. Believing the tire sidewall number. Here is a mistake that shows up in tire shop waiting rooms every single day. A customer comes in for new tires. The mechanic asks what pressure they want. The customer points at the sidewall and says it reads 51 PSI maximum and that they always run them at 50 PSI for better fuel economy. The mechanic takes a breath and explains that 51 PSI is not a recommendation. It is a maximum. Specifically, it is the maximum pressure the tire can safely handle when supporting maximum load capacity at maximum speed. It has nothing to do with what pressure you should actually run. The number on your door jamb placard is the recommendation. It typically ranges from 30 to 36 PSI for most passenger vehicles. The number on the tire sidewall, often 44 to 51 PSI, is the absolute ceiling. It is the do not exceed limit under any circumstances. Think of it like the red line on your tachometer. Just because your engine can rev to 7,000 RPM does not mean you should drive around at 6,900 RPM all day. The red line is a safety limit, not a target. Tire maximum pressure works the same way. When you inflate to the maximum sidewall pressure, your tires become rigid. The contact patch shrinks to a narrow strip. Traction decreases significantly, especially on wet roads. Ride quality becomes harsh. The tire has no flex left to absorb impacts. Every pothole transmits full force to the wheels and suspension. Here is the part that surprises drivers. Running at maximum pressure actually increases tire wear. The center of the tread wears dramatically faster because it is the only part touching the road. You might gain a tiny amount of fuel economy from reduced rolling resistance, maybe 1%. But you will lose thousands of miles of tire life. The engineering teams that designed your vehicle tested it with the specified tire size at the specified pressure. They did not just pick a number that sounded reasonable. They drove test vehicles for thousands of miles, measured tire wear patterns, conducted emergency braking tests, analyzed handling characteristics, calculated load distribution, and determined the exact pressure that delivers the best balance of safety, performance, tire life, and efficiency. That number is on your door jamb, not on the tire sidewall. Number 12. The nitrogen inflation myth. Walk into some tire shops and they will offer nitrogen inflation for an extra $5 or $10 per tire. They will say nitrogen does not leak like air, it maintains pressure better, it runs cooler, and it is what race teams use. Some of that is technically true. Most of it is completely irrelevant for consumer vehicles. Regular air is already 78% nitrogen. When you inflate with nitrogen, you are just removing the remaining 21% oxygen and small amounts of water vapor. Does that provide benefits? Technically, yes, in extremely specific circumstances. Nitrogen molecules are slightly larger than oxygen molecules, so they leak through rubber microscopically slower. The difference for a consumer vehicle over a month is about 0.2 PSI. Negligible. Nitrogen also reduces internal moisture that can cause pressure fluctuations when temperatures change dramatically. This matters in racing, where tire pressure must be controlled to within 0.5 PS1 for performance. The main benefit racing teams get from nitrogen is consistency. They can fine-tune tire pressure to exact specifications, knowing it will not change from heat or moisture. Consumer drivers cannot take advantage of that precision because they are not monitoring pressure before every drive or adjusting for track conditions. Here is what actually matters: checking your tire pressure regularly and maintaining the correct specification. You can do that perfectly well with regular air. Nitrogen inflation will not compensate for ignoring your tires for 6 months. It will not fix checking pressure when tires are hot. It will not override the wrong specification. The problem has never been the air. The problem is driver behavior. If a tire shop offers free nitrogen inflation, sure, why not? But paying extra for nitrogen when you are not checking pressure monthly is like buying premium fuel for a car that does not need it while skipping oil changes. You are solving the wrong problem. The truth is uncomfortable but simple. There is no universal tire pressure. 32 PSI is not magic. It is not even correct for most modern vehicles. What is correct is the specification on your door jamb, checked when tires are cold, adjusted for load conditions, verified with a reliable gauge, and maintained monthly regardless of season. Every shortcut, every close-enough attitude, every blind assumption erodes safety and costs money. Tires are the only part of your vehicle touching the road. They deserve 10 minutes of attention per month, not guesswork, not convenience, not whatever the internet says. Those numbers come from what the engineers who designed your specific vehicle determined after millions of dollars in testing. That information is printed on a sticker in your door jamb. Read it, follow it, check it monthly. And stop trusting myths that were maybe accurate in 1997 but have nothing to do with the vehicle you are driving today. If you found this information valuable and you want to know other critical maintenance mistakes that silently destroy modern vehicles, hit subscribe. The next video exposes a sensor failure that costs drivers thousands in wasted fuel every year, while making the car feel completely normal, and almost nobody knows it is happening until it is too late.